What exactly is at the edge of the observable universe? This has been an enigma that has intrigued scientists and enthusiasts for centuries, sparking curiosity and speculation. However, the James Webb Space Telescope may hold the key to unlocking this cosmic mystery. With advanced technology, it has made groundbreaking announcements about what exists at the edge of the observable universe. When we refer to the edge of the universe, it is important to understand what the observable universe is. This concept includes everything we can see, measure, and study from Earth or through our telescopes and space probes. It is composed of stars, galaxies, and other celestial objects that are within our range of observation. But how does the observable universe differ from the universe as a whole? Simply put, the observable universe is only a small part of the entire universe, which we do not fully know, understand, or comprehend. Although the size and shape of the entire universe remain a mystery, the diameter of the observable universe is estimated to be about 93 billion light-years. To put this in perspective, a light-year is the distance light travels in 1 year, which is roughly equivalent to 5.88 trillion miles or 9.46 trillion kilometers. Thus, the diameter of the observable universe spans an immense expanse, about 546,848,780 trillion kilometers, showing the overwhelming magnitude of our cosmos. Why is the universe so vast? The answer lies in its origin. According to the Big Bang Theory, approximately 13.8 billion years ago, the universe was born from a colossal explosion, giving rise to this unimaginable expansion. This explosive event triggered a rapid expansion, and since then the universe has continued to expand at an ever-accelerating rate, driven by mysterious forces such as dark matter and dark energy. As the universe grew, particles of matter began to coalesce under the influence of gravity, forming incredible structures like stars, galaxies, and eventually planets like Earth. Over billions of years, these cosmic structures became larger and more complex, generating the astonishing variety of objects and phenomena that we can observe in the cosmos today. Despite the vastness of the universe, emptiness is predominant. To put it in perspective, if we were to reduce our entire solar system to the size of a coin, the nearest star would still be 2 soccer fields away. And this is just within our own galaxy, the Milky Way, which is one of billions in the observable universe. Why can't we see the whole universe? There are 2 main reasons. The first is that light needs time to travel through space. When we observe distant objects, we are actually seeing them as they were in the past. The farther away an object is, the longer it has taken for its light to reach us, which means that when we observe distant stars, we are looking into the past and unraveling the history of the cosmos. The second reason is the expansion of the universe. Imagine dots on the surface of an inflating balloon. As the balloon expands, the dots move apart from each other. The same principle applies to the universe, where galaxies move apart as space expands. This expansion also stretches the light from distant objects, shifting it toward longer wavelengths known as redshift. Eventually, some objects will move so far away that they will be out of our observable range. Given these factors, it is not surprising that we have not yet been able to see the entire universe. The idea of the edge of the universe is a fascinating concept that has captivated scientists, philosophers, and thinkers throughout time. Although there are numerous theories about what might lie beyond it, 3 in particular stand out, though the truth remains elusive. The first theory proposes that the universe is eternal and has no visible end. It is based on the cosmological principle, which holds that the universe is isotropic, meaning that it appears the same in all directions. If this is correct, it would imply that the universe extends infinitely without limit. The second theory posits that the universe is finite but lacks a definite boundary. It would be like a giant sphere where, if you travel in a straight line in any direction, you will eventually return to your starting point. The third theory is the multiverse theory, which suggests that our entire universe is just one among many. Imagine multiple parallel universes, each with its own laws and characteristics. These universes could be completely separate or connected in some way. So far, we have explored some theories about the edge of the universe, but now we are going to focus on an extraordinary tool that has the potential to provide new information about this topic: the James Webb Space Telescope, JWST. This impressive telescope allows us to look back in time and discover unexpected objects from the early days of the cosmos. Thanks to its advanced capabilities, astronomers have been able to observe the beginnings of the universe. And what have they found? Something surprising. In a recent study published in the journal Nature, JWST detected 6 massive galaxies that existed between 500 and 700 million years after the Big Bang. Scientists expected to find only small galaxies forming, but the JWST surprised them. These galaxies are much larger than anyone had anticipated, challenging our previous ideas about the early universe. And that's not all, something amazing was also discovered. These galaxies are as mature as our Milky Way, which is 13 billion years old. The mass of the stars inside each of these objects is several billion times greater than that of our Sun. According to the research, one of them in particular could be up to 100 billion times the mass of our Sun. To put that in perspective, the Milky Way contains a mass of stars equivalent to approximately 60 billion suns. You see, this telescope has a special power. It can see things that are invisible to our eyes. Using infrared light, it captures the faint glow of ancient stars and galaxies that have existed for eons. This means that the JWST can literally take us back in time, providing a glimpse of what the universe was like some 13.5 billion years ago. Now here's where it gets really interesting. The universe is estimated to be about 13.7 billion years old, so this discovery has turned everything upside down. It's like rewriting the history books. These giant galaxies, dubbed universe breakers, have scientists scratching their heads. They challenge 99% of the models we had for early galaxies. We used to think that galaxies started out as small clouds of stars and dust, gradually growing over time. Well, these universe breakers proved us wrong. When the Webb data and high-resolution photos from the telescope became available in July 2022, researchers were blown away. They were surprised to see these galaxies as significant points of light, doubting their own interpretation of the data. The sudden appearance of these colossal objects, almost as if they wanted to be found, surprised everyone. By using spectroscopic techniques to analyze light at different wavelengths, scientists discovered valuable information about these galaxies, such as their composition, size, and distance from Earth. What's fascinating is that this groundbreaking discovery wasn't even on the list of things scientists expected to find with the James Webb Space Telescope. It exceeded all expectations and revealed itself much faster than anticipated. There is even a possibility that some of the objects found with the Webb data are something completely different. Let me know what you think in the comments below. If you liked the video, remember to like and subscribe.